All right, so at the end of yesterday's video lesson, I asked you to do the lesson 3 exit ticket, which I attached to yesterday's activities announcement. So that's all we're going to go through today in today's video. Is I want to talk about these two questions because I think they're really good questions, and like I said in yesterday's video, they're representative of the types of questions you want to be able to answer if you've got the skills that this module book is trying to teach. So let's get to it. And also, hopefully you noticed that in yesterday's activity announcement, I said ignore where it says to solve using two different approaches in the exit ticket, and you just solve it in whatever way you like. So it says Jenny's great-grandmother is 90 years old. Okay, and Jenny is 12 years old. Okay, so grandma is 90 and her great-grandma is 90 and Jenny is 12. Okay, what percent of Jenny's great-grandmother's age is Jenny's age? So the fact that Jenny's great-grandmother comes right after the word of tells me that she's going to be like the whole, or her age is going to be like the whole unit in this question, or her age is the thing that we're comparing against. So the whole in this case is the 90 for great-grandma. So that's the hardest thing about these questions, right? Is figuring out, wait, which one is the whole unit and which one is the part that I'm like comparing against that whole. And really this thing that I call the of trick works pretty much every time. There's probably some time when it doesn't work that somebody's gonna be like, well, no, it doesn't work on this one, Mr. Thomas. But most of the time, if you read the way the sentence is structured, the quantity that comes after the word of is going to be the thing that you're comparing against, or in other words, is going to be the whole unit. All right, and so what percent of Jenny's great-grandmother's age is Jenny's age? So that means that the part that we're comparing against that whole is going to be the 12 years for Jenny. And so we want to find the percent. All right, so if you have a part and you have a whole and you want to find a percent, you just divide them. You just do part divided by whole equals percent. And so in this case, that's going to be 12 divided by 90. And so essentially what we're doing is we have a 12 to 90 ratio that we're trying to turn into something over 100, right? Like we want to go 12 over 90 is equal to what over 100? And you could do it with fractions. You could like put another fraction bar here and then try to convert the fraction, or convert the fraction so that it has 100 at the denominator. That's just such a harder way to do it though. Let's make our lives easier and just do 12 divided by 90 equals 0.13 repeating. 0.13 repeating. And so if you move the decimal point over 2 spots, 1, 2, because we're multiplying by 100, you get 13.3 repeating percent. And so, like I was saying, you could do this with fractions by trying to turn 12 90ths into something over 100. But do you see how hard that would be in this particular case? Because we already know the answer is 13.3 repeating, so you'd have to get 13.3 repeating over 100, and you'd have to know, like I guess you'd be multiplying this by 1 and 1/9, because 1/9 of 90 is 10, and then you'd have to multiply this by 1 and 1/9, and 1/9 of 12 I guess is 1.3 repeating, and that would be the harder way to do it. You could do it that way, but I think this is a better way. All right, and so now let's do the next one. It says Jenny's mom is 36 years old. What percent of Jenny's mother's age is Jenny's great-grandmother's age? And so I look at this word of in the question, and the next quantity after it is Jenny's mother's age. And so that means that Jenny's mother's age is going to be considered the whole, or the original unit that we're comparing against in this question. So the whole will be Jenny's mom's age, which is 36. I'll abbreviate that for, this is JM for Jenny's mom. And the part or the quantity in this case, is actually the bigger number. It's the 90 for great-grandma. And so your answer for this one should have turned out way bigger than 100%, right? Like great-grandma is definitely over 100% of Jenny's mother's age. She's over 200% as well, because if you double Jenny's mother's age, you get 72. So she's not quite triple Jenny's mother's age, though. If you triple 36, you get 108. So she's going to be somewhere between double and triple the age, which means her percent should be somewhere between 200 and 300%. So let's take the part divided by the whole. That's going to be 36 divided by 90. Oops, nope. You messed up, Mr. Thomas. The part in this case is the 90. The whole is the 36. That's the most common error that people make when they're doing these questions. In fact, I bet you there's a bunch of students that made this exact same error, and now you just saw that I was about to do it too before I stopped and thought for a second. So if you're making that error, don't worry about it. It just takes time to get used to this stuff. 90 divided by 36 equals 2.5. I'll write it as 2.50. And then I want to multiply by 100 to write it as a percent. So 1, 2. That's 250%. So great-grandma is 250% the age of Jenny's mom. All right, so short video today. What I want you to do is, there's an additional part to today's activities, but also I want you to go back and do anything that you haven't already done. If you didn't do the ST Math or the Freckle or one of the problem sets that I assigned last week or whatever, the fact that you have a shorter video today might give you some extra time to go back and do one of those, get it done now. All right.